Okay guys, this is fossil fuels number 2. Here we're going to focus on oil, natural gas, and some alternatives. So this is about where we left off last time. We were talking about the formation of oil, the difference between coal and oil, that coal is swampy plants that have been buried and exposed to heat and pressure, and oil are marine sediments that have been buried and exposed to heat and pressure, but you just need that extra layer of geology to help you form oil that can be accessed. Okay, and again, just that reserve changes, and our top country right now is Venezuela, followed by Saudi Arabia and Canada, but still the Middle East is the general region that we think of with oil. So here's how oil might form, so just an animation of that. So there's the marine sediments that are falling down. They're going to be exposed to heat and pressure. They're going to form in that rock. But we also are going to need to have that geology that is going to come into play. So it has to be in a porous rock and then also be topped by a non-porous rock. Okay, so here it is just again, that marine sediment falls down to the ground. It becomes buried. It's exposed to heat and pressure. It's going to be forming in this source rock, but then it's going to be capped off by a cap rock, and you have to have that anticline that forms so you can trap that oil in a place that it can be accessed. Whoops. Okay. So once it comes out of the ground, it actually has to be processed pretty heavily. It doesn't just come out of the ground ready to be used. So when we find a source of oil, some of it will come out of its own pressure. But what happens is once that pressure equalizes, we do have to pump another either liquid or vapor down into our well so that we can force that oil out. And we never get all of it out. There's always going to be some oil that's left behind. So here you have your first primary extraction where it's going to come up of its own accord. And then with enhanced recovery, what we'll have to do is we will have to send down another well that's going to be pumping some fluid down so that you can force some more of that oil out. And then even then, it does have to be processed. So this is a hydrocarbon that we can get a lot of different products out of it. You can see some of the products over here. We can get gasoline or kerosene or different types of oils. So this is going to do a good job of showing you how we use that processing and that distillation.
Separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules, and the longer the molecule, the greater the intermolecular force. As you can see here, the small molecules have weaker intermolecular forces, and so will require less energy to break them apart and turn them into a gas. They have a lower boiling point. The longer molecules have greater intermolecular forces. More energy is required. A higher temperature will be needed to evaporate these molecules. They have a higher boiling point. Now we understand how chain length is related to the boiling point of a molecule. Let us look at how this method works. As you can see, crude oil is heated up to a high temperature outside of the fractionating column. The hot crude oil, now mostly in vapour form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some long chain molecules with high boiling points begin to condense back into a liquid. These are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapour, and eventually the vapours get too cool, condense, and are collected as liquids in the trays. Small molecules have low boiling points, and so condense much higher in the column, where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Each fraction has some important uses. Some examples of fractions are petrol, useful as a fuel for cars; naphtha, used in the manufacture of chemicals; kerosene as aircraft fuel; diesel oil, used as fuels for vans, cars and lorries; and bitumen, a mixture of large chain hydrocarbons used to lay roads. Now, at the end of this video, you should understand that crude oil is a mixture of important hydrocarbons, and that fractional distillation is the method used to separate crude oil into useful fractions with similar boiling point. You should understand that small chain molecules are collected at the top of the column since they have lower boiling points, and larger chain molecules are collected further down the column as these have higher boiling points.
Okay, so that did a good job of showing the different types of products we can get from the processing of oil, but also the overall process that we use heat to separate those. And what happens is that as we heat it, it separates based on similar properties. And so from one source of crude oil, we do get a lot of different types of products, including, like they said very briefly, plastics. Not everyone realizes that plastics comes from fossil fuels, from oil. Now, oil definitely has some pros and cons. One of the pros is that it's very easy to transport. We have built pipelines. So here's a section of the Keystone pipeline that's going through. So it is relatively easy to transport, also through tankers. Because it's a liquid, it can be easily stored and transported. It does have less carbon dioxide than coal as a waste product, but it still does have carbon dioxide. Also sulfur dioxide, heavy metals, and then as we saw in our water unit, it does tend to have oil spills, either from the transportation of oil or just from accidental mining accidents like in the Gulf of Mexico, or we have had pipeline accidents where a pipeline will spring a leak and spread oil over a lot of very sensitive habitats. So the thing with oil is we're still very much up in the air about drilling in the United States. We do have a huge resource in Alaska that we have not tapped into yet, that is currently still protected. And Canada, as we saw, is a pretty high energy oil reserve country, and we do have a connection. We have pipelines from Canada, but these are also very controversial. You've heard maybe of the Keystone pipeline or the Dakota pipeline. Those are all tapping into that oil sands resource up, or reserve up in Canada, and having ways to be able to export oil from Canada to our refineries. So when you see those pipelines, it is the crude oil typically that's going through there and making their way to pipelines. And that can be dangerous, and it can go through some sensitive areas and spring leaks. Now, the thing with oil is we don't have as much as we do coal. And so what we're predicting is that the production of oil is going to peak, maybe already has passed its peak, but conservatively by 2050, what we'll have done is hit what we call peak oil. And if you can see this, it's kind of a moving target because as technology improves, we find more oil, and that extends the lifetime of those reserves. So there's no one hard and fast date, but predictably what we're thinking is we have the potential to literally run out of oil in your lifetime. Somewhere in the next 40 to 90 years, we could run out of oil. So this graph is what we refer to as peak oil. That if we take a look at this first one, we will have found all the oil we have to find. And once that's it, we're just going to use it all up. And because it's non-renewable, it won't replenish itself. So here's the first peak, followed by second if we improve technology or reduce our use, and then finally a third one. Now, at one point in the 70s, your parents may remember this, we thought we had hit peak oil, but then technology improved and we found new reserves and it kept on going up. So it still is a very common energy source. And what we use oil for most is transportation. So most of what that oil comes from or goes to is for cars and transportation. Now with coal, remember, it was electricity, and this is transportation. Now, our last fossil fuel that is natural gas. So we had coal was our solid, oil was our liquid, and now natural gas. Now, mostly when we talk about natural gas, it's methane. And if you remember, methane is CH4. But there are other types, ethane, propane, and butane. Up here in the upper hand corner, this is a rather old graph, but it's a little bit harder to find good data on natural gas. But our leading country typically for natural gas is Russia, followed by countries in the Middle East, and then United States. Now, what we use natural gas for mostly is electricity and industry. So if you remember that graph when we were looking at coal, natural gas kind of kicked coal out of the first seat for electricity. So we're starting to use more and more natural gas as a form, as an energy source to heat water, to make steam, to turn a turbine, to make electricity. So that's one of the primary uses in the United States for it. But some of you also might have natural gas in your homes. If you have natural gas heat, you'll know that if you turn on your stove and there's flames that come out, then you have natural gas. So we'll use that for our hot water heaters and our stoves and ovens. Also, it can be used to make fertilizer, or we can liquefy it. So LPG is liquefied, and so that would be like your propane tanks for your grills. And we're going to watch a video in class about how we get to this. The process is called fracking. And so we're going to watch a video in class that goes through fracking and talk about kind of the pros and cons of fracking. And then finally, our last type of oil, I kind of put this separate, even though we do talk now more about oil sand as a oil reserve, because that's what Canada and Venezuela have. But with oil sand, it is literally oil embedded in sediments. And I'll have a sample for this for you in class. And the other alternative that we have that actually the United States has a lot of is oil shale. And that is oil that's embedded in rock. And we get to that oil shale through fracking that again we're going to talk about because it's a very similar way of doing our natural gas. So we'll look at how we access that oil shale. But the key thing about oil sand and oil shale is that there is a lot of pollution that comes with this because of the way that we have to access it. And also that it is not as pure of a source as that crude oil that we might find in our underground reservoirs of oil. And then when we talk about oil sands, there's also a tremendous amount of habitat destruction because it's literally in the sediments. So we have to strip mine with that. And with the fracking, there's definitely the possibility for things like earthquakes and damage to our water systems. But you'll see this graph here, this has a lot of our oil shale in the United States. Now, this is something that might put United States very high in the reserve category if we really start to access this oil shale. So once we start to access that, then this is a tremendous resource of oil right now that could become a reserve for the United States. But just right now, the technology is not quite there, and economically, it's still a resource in a lot of those areas for now. All right, so we're this is going to be the end of our fossil fuel. So we talked about coal, oil, natural gas, and then some of our alternatives. So the one thing we're going to pick up in class is that process of fracking and the pros and cons. So again, you're going to have a graphic organizer of the pros and cons of oil and natural gas.